chose to present this to our insurance company in a class called Active Driving Academy to prove that we know what we're doing. And I'm Zosha, Evan, Mason, and Kayla. So we're going to teach you about reaction time, falling distance, and how it relates to your total stopping distance, speed, acceleration, the relationship of braking distance and stopping distance, and then centripetal force, and what to do at curves, and then yellow lights.
So as far as reaction time goes, things to watch out for are distractions such as your radio, flashing signs on the side of the road, although those are important. People in the car trying to talk to you. There's age. If you're older, your reaction time is going to be slower. Fatigue, if you're really tired, like you just got off an 8-hour shift at work, you're driving home, you're going to have a lot slower reaction time. Alcohol levels, if those are real high, since it's a depressant, you are going to be a lot slower reacting as well. If it's an auditory or visual stimulus, like say you're driving down the road and you hear an ambulance coming, auditory stimulus. Whereas if you're driving and you see a car coming head on, that would be a visual stimulus. And then studies have shown that males have a lot quicker reaction time than females, so that would also affect your reaction time. And reaction time is important so that casualties are avoided, as well as wrecks.
All right, so following distance. Now, it relates to pretty much everything in driving, because following distance, you have to take into account your reaction time, as well as the distance it'll take you to brake. Your braking distance is dictated by a couple things, but I'm not going to explain those until the next slide. Okay, so braking distance, the equation is velocity, the final velocity squared equals 2 times the acceleration in distance plus the initial velocity squared. So basically, your braking distance is how far you'll go when you brake. And it's affected by how fast you're going. Your acceleration, the condition of your brakes, whether or not they're good or whether they've been really worn down from maybe stopping really fast. And then how well your tires grip the ground and how well the road is, whether it's icy or if it's wet. And the way it relates to total stopping distance is because in the beginning, your reaction time, you travel a certain distance. Then you hit the brakes, you travel an even farther distance, and by the time you come to a complete stop, that's where you're at your total stopping distance. And right here is where you have the diagram. It shows different speeds going 20 miles an hour. You have 6 meters of a thinking time, which is your reaction time, and then you drive and you travel another 3 car lengths or another 6 meters before you finally stop. And that's just at 20 miles an hour, and it increases as you go.
Right, and also we have yellow light analysis, which is when you're coming to a yellow light, you have 2 choices. You can either go through the light or you can stop. And they're set up so that you have a go zone where it is safe to continue driving, and stopping, you wouldn't probably be fast enough to stop. And then there's the stop zone, which means you can safely stop and before the intersection hits. And about those zones, there's a dilemma zone, which is bad. You don't want that, because that means there's a spot where you can't necessarily safely stop or safely go because there's too much room. And then also there's an overlap zone, which is good. You want that because that means you can either stop or go at a certain point before the light and be safe about it.
Now, this slide is centripetal forces. Before you go around the curve, you want to start slowing down, because depending on how the road is, whether it be icy, wet, you could just keep going past that instead of actually turning around the curve.
Okay, and then we have terms that are really important that we mentioned throughout the slides.
Speed and velocity. So speed is just how fast you're going, and then constant speed is like speed that doesn't change, and then average speed is velocity, so that's like stopping and going at different times. And then to find the velocity, you do the change in distance over the change in time. And like faster you go, the more potentially dangerous it is if you're going over the speed limit.
Okay, and then here's the stop zone and the go zone equation. This is how engineers are, like people who work on roads, they factor it out to figure out how long to make the lights and also how wide to make the intersections. The stop zone is only affected by your reaction time and your speed and acceleration, because it doesn't, since you're not going to be going, like the length or the time of the light doesn't affect you. And then the go zone is determined by your velocity and then the time of the light, and you take away the width of the intersection because you're still gonna have to get all the way through it.
And then this is the formula for reaction time. Distance equals 1/2 times the acceleration, as well as time squared. And that's a graph right there. It just shows that more caffeine you have in your system, it will speed up your reaction time, and alcohol will slow it down.
Okay, and then acceleration is this is how fast you're speeding up or slowing down. And if you're speeding up, it's positive acceleration, and if you're slowing down, it's negative acceleration. And the formula is the change in velocity over the change in time. And this graph is showing you an example of positive acceleration. So this person is speeding up as they're going.
Centripetal force is a force that keeps an object in motion during a circular path, and centripetal acceleration is acceleration when an automobile changes direction. To find centripetal force, you multiply the mass by the velocity squared, and then take all that divided by the radius of the turn. And like Evan said earlier, like turning, you have to go slow when you go around a curve because that your car could just run off the road if you don't.
That is it.